Like alright, I guess.
Better watch out in case they're like here.
Have we started already?
Yeah.
Okay.
I'm just like changing some stuff. Oh shoot. I think yeah, we're on, and it's on public. But we'll start at like 8:10 or something.
Okay.
Crop. Yeah, cool. I'll make us a little bigger. Right. And I'll have the stream on my phone so I can actually see. Alright. Looking good. Do you want to circle the physics questions you'll be doing? 469.
Yeah, sure.
I'll just message some of my students. Oh, you're not tutoring anymore, right? With RL, because they're done.
Yeah, yeah. But I think they're starting real soon.
Right. Hello, everyone who's joining. Who joined? Alan.
Wait, you have Spesh students?
Nah.
Oh.
But I have like students who do Spesh as well.
Oh.
Yeah. Like I had to teach them English. Hello, Sleepy Pogger. I think Sleepy Pogger's been to a lot of these.
Yeah.
Nashi, what time approximately? Spesh will probably take like 40 minutes, I reckon. Maybe like 8:50. Start doing physics. Hello, Hayden.
Yeah, I should probably study for it.
Is that the coding thing? You did well last sem,
Yeah.
didn't you? In it.
Yeah, I did pretty well. But I think this sem's a lot harder.
What language are you doing?
C language. It's like a really old one.
I think Jamus doesn't want to repeat another subject again. You gotta help him study.
Yeah, he has two to repeat. There's two to repeat.
Hello, Hui. Hello, Liam. Sure. Yeah. Physics will be around. I'll just probably type it in the chat. Physics around 9. I'll just say physics 9. Pin message. Cool. We'll start at like 8:10.
Sure.
Oh, Yash. How was biology? Was that Friday or? Have you looked at the exams for this year that they had to do?
I've only looked at methods exam 1 so far.
Apparently it's easy, I think.
Apparently it was easier than last year.
Oh.
But some people also say last year was pretty hard.
I thought last year was okay. The exam. I thought exam 2 was pretty hard.
Mm-hmm.
Oh no, we're not going through whole exam 2. So Spesh, we're going through just multiple choice. And then physics is multiple choice plus 3 extended response questions. Yeah, Alan, there's always time to support the stream. What's 9 hours? Is that like how long he promised to study or something? Special exam 1 was ugly this year. Was it? In what way was it ugly? Does physics scale? Scales like 2, doesn't it?
Yeah, 2 or 3. Same as chem.
Yeah. Did your chem scale to 48? Or was it just 47 points on?
I think it scaled to 48.
Spesh 1 was annoying. Are you doing methods in year 10, Alex? Is that how it's working? I think algebra and Spesh is always kind of like messy. You need to do a lot of lines.
Yeah.
Especially exam 1. That's how they like test you. Are you getting promoted next year within the RL organization?
I probably will. Probably
Yeah.
get a pay rise.
Nice. Yeah, so we'll be starting at 8:10. And we'll be going through Spesh MCQ, Physics MCQ, and some extended response. Okay. Methods topics at the moment. I mean, 1-2 methods is pretty similar to 3-4. Apart from, like, some of the harder stuff, I guess. Like binomial and things. Do you have any tips for year 11, Gordon?
For special physics, I mean, I think it's really worth focusing on special physics because there's like overlapping content. So if you like, get your head around dynamics and forces and stuff, then it's really worth it.
Yeah, I mean, show that questions are good, I feel like, because you get the answer. You kind of know whether you're right or wrong. But yeah, I guess they're also annoying if you can't get it. Do you have general advice for the physics exam?
I guess for physics, the content is not like too hard. I guess just the hardest bit is definitely like being able to explain stuff and also being like really meticulous, like, because there's a lot of ways you can lose marks in physics for not being careful with the answers.
Yeah, I don't think methods and Spesh are that similar. I feel like Spesh builds on methods and some of the stuff overlaps.
Yeah.
Yeah, but I feel like a lot of topics in Spesh, you don't cover it all in methods. And with physics, we're going through multiple choice and 3 of the extended response questions. Hey, Mitch. Mitch is one of my students. I taught him English.
Oh.
And he kept asking for a physics and Spesh stream. Physics stream mainly, during our lessons.
Is he year 12?
Yeah. Very rural school, I think.
How did you go on the inline exam, was it? Or
English.
just normal English?
I think... Yeah, no, he never told me afterwards. Mitch, how'd you go on the English exam? Am I insane for doing Bio 3-4 in year 11? I think quite a few kids do it. Do Bio 3-4. But it's good that you're doing a 3-4 in year 11. And I think Refrigerated has a question for you. Did you drop any marks from the physics exam to get 50?
I actually don't know because I didn't check my exam paper. But I know Ichin told me he dropped like 2.5 and he got a 50 as well.
Mitch, I told you to tell me how you went like before the exam. You meant to report back to me. I don't ask in case like people are like upset or something. But yeah, how did you go? I'm curious to hear. Oh, 2, 3, 4s. Yeah, Gordon and I. No, I did that. You just did Chinese.
Those are Chinese, yeah.
Yeah, I did methods Chinese. I think Scotch is more strict on who can do 2, 3, 4s compared to other schools. Other schools, I think a lot of people do it, but I think you could have done it if you wanted to in year 11. Anyway, why didn't I do bio? I didn't have a subject I could switch bio for. So yeah, I probably would have done physics actually if I had to do another subject. I feel like it just fits more. All right, how about let's get started then.
Yep. Okay. So for the first one, like when we're interpreting these graphs, we can just do it by process of elimination. So obviously x can't be 1 here, right? So that's going to be a vertical asymptote. So obviously the graph is going to have a vertical asymptote. So that's not the right answer. And if we think about what an approach is when going to negative infinity or infinity, when x goes to negative infinity, e to the power of x is going to go to 0. And x minus 1 will go to infinity. So we'll go to negative infinity. So I guess that in that case, this value in total will approach 0. So that's going to be a horizontal asymptote. And the vertical axis intercept is obviously just another way of saying y-intercept. So you can just sub in the value of 0 and see if f of 0 actually exists. And the two answers left, you can just verify by putting into CAS and graphing and see if it has a local minimum or a point of inflection. And the answer for that question is actually just E. And for question 2, when we are working with like fractions with polynomial on top and at the bottom, to find the asymptotes, we need to first simplify it and take variables out, because that will give us a clearer form of what the asymptote is. So in this case, if I just put this in the CAS, put fs in the CAS, and tell it to simplify, it will give us x on 2 plus 2 plus 17 on 2x minus 8. And obviously, because of this denominator, we're going to have a vertical asymptote at x equals 4. And also, we need to consider what fx approaches when x approaches infinity or negative infinity. And in this case, we know actually that this fraction term is never going to be equal to 0, right? So fx is never going to be equal to x on 2 plus 2. So that's going to be the y equals x on 2 plus 2 is going to be another asymptote. So the answer will just be C.
Yeah, with these questions, there's a lot of ways to check, especially in multiple choice. Like you can just draw that and then draw the asymptotes and see if they actually never intersect. Yeah.
Yep.
All right, question 3.
And for question 3, obviously we can just simplify fx to 1 minus 1 over cosine of x plus 4 pound 4, right? And obviously the asymptote, the domain of this graph depends on what x cannot be, right? If x is a value such that cos x plus pound 4 is equal to 0, then we're essentially dividing by 0, which leads to undefined answers. So the restrictions will be the solutions of cos x plus pound 4 equals to 0. And from this point, it's just sort of a general solution question, because we know that x plus pound 4 must be equal to pi on 2 plus k pi, because when we have pi on 2 plus k pi, that's going to be these 2 points. And at these 2 points, cos is equal to 0. So now we can just simplify x equals to pi on 4 plus k pi. Obviously, k is an integer. So x equal to pi plus 4k pi over 4. That's equal to pi 4k plus 1 over 4. So yeah, so k is just n in the actual solution, so we choose D.
Looks good.
Okay, and for question 4, the trick here is to identify that when we have 4 factorial or anything higher, so anything like 5 factorial all the way to 100 factorial, these numbers are all divisible by 4, right? Which means because I to the power of 4 is equal to 1, and 1 to the power of anything is just 1 itself. So we know that for I to the power of 4 factorial, all the way to I to the power of 100 factorial, these terms are all going to be equal to 1. And we know we have 97 of these terms, right? So 97 times 1. And then now we consider the rest of the terms, which is the first 3. So I to the 1 factorial is I to the power of 1, that's just I. And I to the 2 factorial is just I to the power of 2, which is negative 1. And I to the 3 factorial is I to the power of 6, which is just 1 times 1 times negative 1, so negative 1 again. So we have I minus 1 plus 97, which is 95 plus I.
Yeah, and with Josh's question in the chat, if you guys also did the accounting exam, I guess you can input into this. I never saw the accounting exam, never did accounting in my life, so can't really help you there.
Okay, so for question 5, when we see argument equals an angle, we can always break these down into Cartesian formulas. So in this case, z obviously can be, we can let z equals x plus yi. And then in that case, argument of x minus 2 plus yi will be equal to pi on 4, which means that y on x minus 2 equals tangent of pi on 4, and that's equal to 1. So essentially y equals x minus 2 for the first equation. And then for the second equation, same idea, argument of x minus 5 plus y minus 1 I equals 5 pi on 6. So y minus 1 on x minus 5 equals tangent of 5 pi on 6. And tangent of 5 pi on 6 is equal to negative 1 over 3. So y minus 1 equals negative 1 over 3. X minus 5. And obviously we can just move the plus 1 onto the other side. And obviously when we have two Cartesian equations, we can just pop it into the CAS to solve for an answer. And the solution will give us that x equals 2 plus root 3. And we also know that y equals x minus 2. So that's equal to root 3. That answer is D.
With question 4 and 5, I think someone said question 4 was weird. I think the main point is that I to the power of 4 is just 1. That's sort of the main point, the main special quality of I. And with question 5, I think with graphs there are also some forms that occur a lot. Not really for argument, but for some of the other ones, like it's a line where they say that the mod of one thing equals the mod of another. Fairly sure that's a line. Yeah, that's a line.
Yeah.
So there are some common forms that you'll see a lot and you'll probably learn.
So I guess for question 4, the point is that if you have, because 4 factorial to 100 factorial, these numbers all are divisible by 4, right? So we can just write it as I to the power of 4 times a, right? So a can be any number because it's divisible by 4. So a will be an integer. So that's just equal to I to the power of 4 to the power of a. So that's just equal to 1 to the power of a. So it's going to equal to 1. Doesn't matter what a is.
Yeah. I think for me in the actual exam, I didn't realize that, but I still got the right answer because I just typed in like I to the power of 100 factorial or some of the numbers in there. And I was like, oh, they all look like 1. So I'm just going to run with that. And
yeah. That's another way to do it.
Yeah. The what do you call it? The shovel.
Yeah, the shovel, yeah. Okay, so for the next one, I'm gonna use the Morse theorem, right? So the Morse theorem is basically when you have something in polar form, say r cis theta, and you raise it to the power of n, that's just equal to r to the power of n times this cis of n theta. Which means, so because argument of z equals pi on 4, argument of z to the power of 4 is just gonna be z to the power of 5, sorry, it's just gonna be 5 times pi on 4. 5 times pi on 2, actually, sorry. 2, that's going to be 5 pi on 2, but obviously we have to put this as an argument form because argument must be less than pi on 2 and greater than negative pi on 2, less than equal to pi on 2. So that's just going to be equal to pi on 2 because 2 pi is a period. And we can do the same thing with the argument of w to the power 4. That's just 4 times pi on 4. That's just equal to pi. Oh, actually, sorry. That should be pi. The range for arguments is between pi and negative pi, with pi inclusive. Yeah, and then obviously we're dividing z to the power 5 by w to the power 4. So that's the argument of that is just going to be the argument of z to the power 5 minus argument of w to the power 4, which is pi on 2 minus pi, which is negative pi on 2. So A.
Also, with de Moivre's theorem, I think my tutor got me to prove it, but essentially, if you think about it, r cis theta times r cis theta times r cis theta n times, right? When you multiply two polar forms, you multiply the thing at the front, so it's r times r n times, and then you add the arguments, so that's why it's n theta inside. This is a side thing.
Yep. Okay, the question 7 is the length of the curve, right? So when we have a curve that's formed by parametric equations, the formula for arc length is just equal to antidiff from pi to 0. So because t is from 0 to pi here. And then we square root dx dt squared plus dy dt squared dt. Yep, so in that case, it will just be equal to pi to 0. And that's going to be 9 cosine squared t plus 16 sine squared t dt. And obviously we know that the identity is cosine squared t plus sine squared t is equal to 1. So that's just going to be equal to root 9 plus 7 sine squared t dt. So B is our answer.
Yeah, I guess for that, you can use the formula sheet. I use the formula sheet quite a bit because I knew them, but like I just wanted to be safe. And also when you look at the answers, you see some of them have cos and sine, but then when you realize your cos and sine one doesn't match any of them, then you try like just sine. Yeah, because none of them are just cos, so you try just sine as Gordon did.
Yep. And for question 8, normally I just substitute what's inside the log. I mean, what's inside the square root, sorry. So if I take u as 2x plus 1, then obviously du dx is equal to 2. So dx is equal to du divided by 2. So I can, obviously I have to fix the terminals because u equals 2x plus 1. Then u when x equals to 5 will be equal to 11. And u when x equals to 1 will just be 3. And you will have u minus 2 here to get 2x minus 1. And then you will have square root of u du divided by 2. So you can take the half to the front and then 11, 3, and you'll have u to the power of 3 on 2 minus 2 u to the power of a half du. And that'll be E, I think, yeah.
Yeah, with these questions, you can literally just type them in and see if you get the same answer for both. Happens a lot. Sometimes they can't evaluate it, which is annoying, but yeah. And also, I try not to talk about scores too much in the chat. I guess you can talk about the difficulty of exams, but you don't want like other people to feel bad. And we're sort of halfway through exam period as well. Cool. All right. Question 9.
Yep. So for question 9, we just gotta look for key features. Like one of the really obvious thing in this graph is that there's a line here, right? So when y equals to x, gradient dy dx, or the gradient, is somewhere similar to 1, right? So if you think about when we sub y equals x into these formula, that's going to be equal to sine of 0. That's going to equal 0. So that's not what we actually want. Yeah, so same thing with this. Cos of 0 is equal to 1. So that's potentially an answer. And this is the same thing, sine of 0 equals 0. And here we have 1 over cos of 0. So that's also going to be 1. So that's also potentially an answer. And here we have 1 over sine of 0. And that's just going to be 1 over 0, which is undefined, right? So undefined will look very vertical. So that's also not what we want. So from these two, I guess we can look for other key features that are present in the graph. So for example, I can see a pretty flat line here, right? And that's probably around x equals to 0 and y equals to 1.5, right? So let's think about like cos of 1.5 and 1 over cos of 1.5. And 1.5 is actually really close to pi on 2, right? So when we think about pi on 2, when we think about cos of pi on 2, cos of pi on 2 is equal to 0.
Yep.
Yep. So which means that in this case we actually choose B instead of D because the gradient of the line is very flat, right? So it'll be close to 0.
Yeah. With these questions also, I'm pretty sure you can draw parametric equations. I don't remember how to, but you can also draw them on your CAS. But this way is like a bit quicker. And also the parametric equation, sometimes the resolution doesn't match, so it might look a little different. But it's a good check at the end.
Yeah. Okay. Moving on to question 10. Sand falls from much. So obviously the given information here is that because sand is added to the pile at a rate of 1.5 meters cubed per second, we know that dv dt is going to be equal to 1.5. And obviously there's an angle of 60 degrees here, right? Which means if this was h, we know that tan of 60 degrees is going to be equal to root 3, right? So this radius here, radius must be equal to root 3 times h. So obviously the thing that we want to find is the rate at which h is changing, right? So we want dh dt, and we have dv dt already. So obviously dh dt equals dv dt times dh dv, right? So we need to find either of dv dh or dh dv. So let's find the formula for the volume. So volume of a cone is just equal to v equals pi r squared h on 3. I think that's in the formula sheet as well. And because we have this relationship here between r and h, we know that r squared is just equal to pi 3h squared h on 3. So that's just equal to pi h 3. Now we just need to differentiate it to find dv dh. dv dh is equal to 3 pi h squared. So now we can, there's two ways we can do it. We can just sub h in right now and find dv dh, or we can combine 1.5 and 3 pi h squared together, and then we sub in h. But in the end, the answer will always give us c when we put it into the CAS.
Also, someone asked me whether I'm doing a Chem one. I probably don't have time to, because it's in a couple of days. unfortunately. But you feel free to ask me questions, and if I don't know, I can ask some of my friends who did better in chem. Gordon actually did well in chem, so you have good questions. If you have questions like about general chem prep, you can probably ask him.
Yeah.
Also, someone asked, do you think MC or ER first for exam 2 Spesh?
Well, I like to. So the way I spend my reading time is just I just walk through the MC and I read each of them, and when I have a way of doing them, I just skip on to the next one. So I guess for me, I just do the MC first because if I do it later, then I'll probably forget the way to do them. So yeah, this is my approach.
Yeah. For me, I did extended response first because that's sort of the way my tutor did it, and I liked figuring out like how to do the extended response rather than MCQ. So you just try out different ways, and you should sort of have your way fixed by now. Considering the exam's not that far away. Also, I prefer you guys don't talk too much about scores and answers and stuff because you're gonna make like people like sort of angsty about the exam. You can talk about like generally how hard it is, but specific answers, scores, you can sort of search that up in your own time. Oh, someone asked, do you know how many marks you can lose overall for a Rule 50 in Spesh?
I'm actually not too sure about that. I think it's roughly around 5 for methods, but I'm not too sure about Spesh.
I'd say Spesh last year would probably be like probably around maybe a bit less than 5, like 3 or something.
Yeah, I think Spesh last year was pretty easy.
Yeah.
The paper, yeah.
But usually it'd be a bit higher than that. Like you could lose a couple more marks.
Yeah.
All right.
Okay, anyways, for question 11, so we know that the midpoint coordinates is -5, root 3 on 2, and C, right? So when we try to find the midpoint of the line that connects two coordinates, we just have to find the average value between the coordinates. So in this case, the average value of x will be a plus -3 over 2, and that's just going to be the midpoint coordinate, which is -5 in this case. And you do the same thing for every coordinate. So 1 plus b over 2 is just going to be 3 on 2, and -2 plus -1 over 2 is just going to be c, right? So in this case, a would be -7, right? B will be 2, and c will just be -3 on 2. So the only answer that satisfies that is E.
Looks good.
So the next one is a vector resolute question, and obviously there's a formula for that. The formula is that if we have vector resolutes of u in direction of v, then the vector resolutes formula is just u dot v divided by v magnitude of v squared times v itself. So in this case, if we want to find the vector resolute of I plus j minus k in the direction of mi plus nj plus pk, that's just going to be, first we find the dot product, which is just m plus n minus p, and then the magnitude of the second vector squared, which is just m squared plus n squared plus p squared, times the second vector itself, which is mi plus nj plus pk. And that's going to be equal to our vector resolute, which is given to be 2i minus 3j plus k. So if we look at option A, that's just matching each coefficient with the coefficient in the given solutions, right? So if I take m to be at the front, that will just be equal to 2, which is just what the answer suggests for A. So I guess the answer for this is just A.
Yeah, I don't think scaling will be better. Like, I don't know. I don't think scaling changes much year to year, honestly, especially for a subject like Spesh. I think Latin, it might change because a lot more people are picking up Latin. Whereas Spesh, I think the number of people doing it has been pretty constant. And it's always usually like 50 goes to 55 and maybe small differences. I don't know how to say this guy's Chinese name, but he asked, which bound reference would you choose, textbook or notebook? Gordon, what was your bound reference?
I don't have one, but I'll definitely choose notebook over textbook.
Yeah,
What do you think, Darren?
Yeah, I agree. I think textbook is sort of like a panic thing. Like people just staple their textbook to like things. Yeah.
Yeah.
But I think you should if you legitimately like a really really find Spesh really really hard, then and you have literally no notes, then go with your textbook. But I think notebook is sort of individualized to you and it will make you feel more comfortable as
Yeah.
well. And AJ asks, also Gordon's with an O by the way, unless I spelled it wrong in the thing. But
No.
okay. Were you expecting a 50 before going into the exam last year? What was your aim personally? How did you handle the nerves so close to the exam?
I don't think I was aiming for a 50, but I had a pretty high aim, I guess, because my ranking was pretty good, right? And handling my nerves, I feel like it's just a really natural thing. Like you go into the exam really nervous, right? But as you get into like doing questions and stuff, you sort of like forget about it, and you just like in the mode of doing questions.
Yeah. So you focus on the questions. You don't think too much about other stuff. Just do the
Yeah.
questions.
Okay. Question 13 then.
What was your favorite part of Spesh? Did you have a favorite like topic?
Favorite topic? I guess dynamics was probably my favorite.
Is that the
But
physics stuff or is that like the
yeah. It's like the one with forces and stuff. I feel like it's pretty interesting.
I liked imaginary numbers. But yeah, that's just me.
I feel like imaginary number is like really abstract.
Yeah.
It's like hard to understand.
Whereas dynamics and stuff's actually useful. Like people actually use it.
Yeah.
Fair.
Okay. Anyways, for two forces, F1 and F2. So obviously the equation here we're going to use is F equals ma. Because the produced acceleration is root 3 I plus j. So the total force, or F net, will just be m times a. Obviously, a is a vector. That's just going to be 3 root 3 I plus 3j. That's F net, right? So obviously, we know that there's two forces, F1 and F2, and combined, they're going to produce F net, which means that given that F1 equals 2j plus F2 is just going to be 3 root 3 I plus 3j. So F2 must be, or the vector F2 must be 3 root 3 I plus j. So now we have both F1 and F2. We just need to find the angle, right? The angle is what we need between F1 and F2. And because they're both vectors, a really easy way to find the angle is using the cos formula, right? So cos theta, where theta is the angle between the two vectors, is just equal to the two vectors, the dot product of two vectors, F1 times F2, divided by the product of their magnitude. Yep. So here the dot product will just be 2 because F1 doesn't have a I component. And the magnitude of Fi is just 2, or square root of 4 or 2, yeah. And the magnitude of F2 is going to be square root of 27 plus 1. So that's just equal to 1 over root 28, which is just 1 over 2 root 7. Which means that the angle between them is just going to be cos negative 1 of 1 on 2 root 7. And because this is a positive number, right? So when we think about if cos of an angle is a positive number, then it's going to be less than 90 degrees. So we don't have, so hence an acute angle. So we just choose D.
Cool. I'll just answer Andy's question. Do you recommend going to Ing Lang 3-4 without the 1-2? I think if you feel like you'll actually do well in Ing Lang, then and like you're really struggling with English, then it's a good choice to do. In terms of whether it's hard or not, I don't think it's particularly hard to pick up 3-4 Ing Lang without doing the 1-2. So if you feel like you have a reason to do it, then I think go for it. Oh, okay, I'll answer some more, I guess, because we just have some more. Random as songs play in your head. Did you have that?
As randoms as songs play in my head. Not really. Not really.
Yeah, neither. It's more when I do sport or something. I have songs playing, but not like when I do maths, probably. Yeah, and when Gordon said you can lose 5 marks, it's 5 marks total. Like, I don't know. I don't think adjusted stack scores play that big of a part. Yeah. If you read the question, what do you think?
I think you can lose 5 marks on the actual exam, and obviously it depends on also depends on how good your stack score or your ranking is. But if with a decent ranking, I think, well, if you lose 5 marks on a method exam, you can still get a 50.
Yeah. Highest derived score. I don't know anyone who's gotten a derived score. Do you? No?
Well, what do you mean by derived score?
Like they didn't sit the exam and they got their score like from the GAT.
Oh, nah. I don't think I've seen anyone getting that.
Yeah. If any of you guys have friends or whatever who did, feel free to drop in the chat. I'll be curious to hear as well. But yeah, I don't think many people at Scotch got derived scores. And Demarcus asks you whether you did a 3-4 in year 11.
Yeah. I did Chinese in year 11.
I just read Andy's question.
Yeah. My Chinese name is Jingyan. Yeah.
Yeah. So you've probably seen like in like the newsletters and stuff. It's Gordon. And AJ asked you how many marks you lost in the methods exam.
I lost 2 marks on the methods one. Yeah.
Yeah. Gordon got premiers for both methods and Spesh, which is like top of the 50s. Like out of the people who got 50, you get the highest exam score. So we dropped 1 in Spesh, right?
Yeah. Actually, I've seen people who didn't get a 50 but get premiers.
Oh, what?
It's like, yeah, because in Chinese, like there's not that many people doing it, right? So there's only like one guy who gets 50 or like one guy who gets 49.
Oh, yeah.
And people who get 49 also gets premiers as well.
Yeah. I thought you meant like in like Spesh or something. Someone got like 4 marks exam, but it was like ranked last and then gets premiers.
No. Okay, let's move on to the next question then.
Sounds good.
Yeah, so this is another physics question. Like when we consider this whole thing as a system, the total downwards force, because there's 2 kg here and 1 kg here, that's a total of 3 kg, right? So the Fg, or the force of gravity here, will just be 3 times g, where g is 9.8. G is 9.8. So that's the force, and obviously the mass of the system, we have to consider 4 kg as well, right? So the mass is actually just 7 kg in total. And when we have F equals ma, 3g, the force, will just be equal to 7a, right? So a will just be equal to 3g over 7. That's the acceleration of the system. And now we want to find the tension, right? So tension is, when we want to find tension, we can look at individual items here, right? So the 1 kg here has a downward force or force of gravity of a g, right? So 1 times g. And it has an upward force of t, right? So the net force that this 1 kg experiences is actually just equal to g minus t. And that's just going to equal to ma, right? So because its mass is just equal to 1, that's just equal to a, which is 3g on 7. So t is equal to g minus 3g on 7. So that's equal to 4g on 7. That's just a.
I think my teacher didn't really like me doing net stuff, but I guess, I don't know why. But so I'd do each one. I'd like draw out the forces and stuff. But I guess if you do physics or if you're good at this kind of thing, you don't really need to. Um, Also, it's a rest, so you can kind of go either way you want. But sometimes when there are like when it's not at rest, it's useful to think about which way it's going. So then when you do your like the F net thing, it might be the other way around. It might be easier because you get a positive acceleration. Yeah.
Yeah. Okay, and for 15, it's sort of like mirroring a scenario where we have projectile motion, like when you have an object on a cliff and you have a horizontal force of speed and it drops off, right? It's because the AJ here sort of refers to the acceleration, like the force of acceleration that it experiences as it leaves the platform. And so the statement that describes this sort of motion is just projectile motion, which means a parabola. And obviously, like if you look at A and B, these are obviously like not right, just based on logic. And for a particle to move in circular arc, there must be an acceleration that's centripetal, right? So initially when it's traveling this way, the velocity is that way. The acceleration must be perpendicular to it, right? And as it turns around, as it's falling, for it to continue in circular motion, there must be acceleration this way, right? That's centripetal. That's towards the center. But here we only have acceleration that's downwards. So it's not perpendicular to its motion, which means it cannot be circular. But this is more like physics knowledge.
Yeah, I guess you can. I'm pretty sure I did it mathematically. I don't remember how because I have not looked at Spesh in a very long time. But I think even with just Spesh knowledge, you can sort of think about what Gordon says and just logically. Right, for something to go circular, you have to have it like an acceleration going semi backwards. Otherwise, it's just going to keep going like forwards, and the acceleration is not impacting its like its I direction, like forwards or back. So it's not going to do anything to that.
Yeah, I think, yeah. So if you want to do it mathematically, you can just say A equals AJ, right? So when you want velocity, just anti-diff it. So that will just give you ATJ. But obviously there's an initial velocity of UI. And then you want to find the position, which is what you're looking after. That's just equal to AT squared J plus UT I. Yep. And I guess that sort of implies that it's a parabolic motion.
Yeah, because x equals ut, right? And y has a t squared, so y would equal x squared, something in there. Yeah.
Yep.
Yeah. Yeah, refrigerated. Some subjects, I think, not many people do it. So the highest is like 48, 47. Ace, hello, welcome. You've been to a lot of these. Thank you. Demarcus Cousins asks you what you're studying and where.
What I'm studying? I'm studying data science at UniMel.
Yeah. Yeah, it's not physics yet. We're getting close to physics. 0. How would you say you cope with getting a worse exam 1 score? So I didn't do that well on exam 1. I lost like 2 marks, I think, on every single exam 1 I did. Like year 11 methods, year 12 methods, year 12 Spesh. Like it's a bit of a joke. I would say like you just got to focus on the next one, right? Like the only thing worse than doing badly on exam 1 is letting that impact your exam 2. Just really focus on doing well on exam 2 and your following exams. Because like there's not much else you can do. Like you can't really change your exam score. You can think about what you did wrong though. Gorma says I dropped 40 marks on exam 1. Not ideal. Mikhail, thank you for joining. Hello. He says hello to both of us, Gordon.
Oh, hey, Mikhail. How are you?
And Andy asked who tutored you for maths and physics.
Okay. So I didn't get a physics tutor, but I went to RL for math. So it's like an organization that has campus in Boxhill and City.
Yeah. You want to tell them like the opening hours? Yeah. Do you enjoy data science?
Yeah, so far I feel like it's pretty good. Pretty good. It's a lot of math and programming, yeah.
And did you use SAC cheat sheets for your exam material for physics, or did you create your own? Create a new one? Oh, did you use your SAC ones for the exam, or did you just make a new one for the exam?
Um, I just use my SAC ones. Yeah.
Yeah. Hello, Emmanuel. What do you reckon out of 120 correlates to a 45 in Spesh? Last year was a bit of an easy exam. I think I dropped like 6 or 7 in Spesh in exam 2 and like 2 in exam 1. So probably 9, 8, 9, 10 ish got me a 44 raw. So it'd be around that. Gordon got 50 for both methods and Spesh. Did he both get? Yeah, we both got 99.95. Did Gordon get tutored by Ricky? Someone asked. Was he a tutor?
Yeah, yeah.
Oh. Nice. Right, question 16.
Okay, question 16. Yeah, so the value that we're looking for is just acceleration, right? And the information we have is v in terms of x. So because we know that an expression for acceleration is v dv dx, right? So we can just pretty much write it as ex sine x times dv dx, and we just differentiate this. That's just going to be ex sine x using product rule plus ex cos x. So yeah, so instead of dv dx, we could just write ex sine x plus ex cos x. So that's going to be e2x sine squared x plus sine cos x, sine x cos x. And we just have to find an equivalent answer in here. And I think it's just A based on double angle formula, because sine 2x equals 2 sine x cos x.
Yeah. I guess a big one with these is oftentimes looking at the ants. Oh, okay. There's 2 parts of this. One is like knowing the different acceleration formulas, when to use them. And also looking at the answers, because there's a lot of things you can do with trig functions. And so you kind of want to know roughly what your answer will look like. So then you can use the appropriate like double angle or something else. How good, Mikhail asked, how good would it be to get a 40 plus? I think it's 9% get a 40 plus.
Yeah, yeah. Because study score is apparently normally distributed.
Oh, yeah. Cool. Moving to question 17.
All right, 17. So usually when I do these sort of questions, I like to redraw this as a triangle just because it's in equilibrium. So I know we'll be able to draw a triangle from it. So if I have F1 here,
Wait, let me just say something. Sorry.
Yeah.
Ozek, yes. I've got a Latin exam video coming out tomorrow. I recorded it today, and because I realized the Latin exam is really close, and it'll be coming out tomorrow. Hopefully, it gets like more than like 3 views. But, yeah. Good luck for your Latin exam on Tuesday. And yeah, I guess 45 is pretty like rare. But I wanted to get higher, but it didn't end up happening. But yeah, thank you, and good luck for your exam. And do check out that video that's coming up. And also your class will probably do Latin as well, so do recommend it to them as well. Yeah, my bad. Continue with question 17.
Okay, yeah. So in the case that this is F1, then this is F3 and this is F2. And by moving the vectors around, we actually change the angle here. So this angle here would actually be 180 minus beta. And yeah, so this angle here will be 180 minus gamma. And this angle here will just be 180 minus alpha. And here, because we have a triangle, we can actually just use the sine rule. So F1 over the angle that it's pointing to will just be over the sine of 180 minus alpha will just be equal to F2 over the angle which is equivalent to that. So that's sine of 180 minus beta. And because the thing with sine is that sine of 180 minus alpha is just equal to sine of alpha. So F1 over sine of alpha equals f2 over sine of beta, which means that f1 over f2 is just equal to sine of alpha over sine of beta. And the information we're given here is that beta equals 2 alpha, which means that we can simplify that to sine of alpha over sine of 2 beta. I mean sine of 2 alpha, sorry. And with double angle formula, we can cancel it out. So 1 over 2 cos alpha, and that is equal to sec. 1 over cos is equal to sec.
With these questions, there's different ways to do it. I like the triangle. You can sort of think about, like, if you extend or if you move f2 sort of down, right, like vertically downwards, and then you bring f3 to like fix that to make it into a triangle. I like to think about it that way. To make the triangle.
Yep.
Nah, just get a 30 in Latin. Yeah, I had a friend who got like a 20 something, like 27 or something in Latin, and got like a 46. It was by far his highest scaling subject. It is a pretty broken subject, pretty hacks. Yeah, thanks for agreeing to watch the Latin video. It's pretty interesting though. Yeah. Do you have to do UCAT in interview? Yes, you do, for Monash. Refrigerated asks, can you use Lami's theorem for these?
Yeah, you can, definitely can.
Yeah. I think there's multiple ways. You can do Lami's, you can do that. Or you can sometimes make like a right angle thing as well. There's just different ways to do forces questions.
Yeah.
And just final question. Is it still possible to get a good score if you didn't do well on exam 1? Yeah, definitely. Like you just do well on exam 2. Yeah. Like don't lose faith. You just gotta work hard. Like not lose your like your momentum. You don't want to lose your momentum just because you didn't do well on one exam. Did you have an exam you didn't do well in? No, you did well in like all of them, didn't you?
Oh, like Chinese last year. I mean the year before.
Yeah. But like during exam period, you didn't have like an exam that you were like, oh, I could have done better.
Yeah, I guess, yeah.
Cool. We can do 18 then.
Yep. So for question 18, that's a confidence interval question, right? So whenever we have confidence interval, we have to use inverse normal. So I guess here, because we have a sampling proportion, right? So the mean will still be equal to 65 p hat sampling proportion. So that's equal to 65 still. But the standard deviation will be the original standard deviation, which is known to be 4 kg, divided by root n, right? So root n here will just be 36 because the sample size is 36. So that's 4 over 6, that's 2/3, right? So now we have the standard deviation and we have the means. We just have to put it into inverse normal, and we have to input values, right? We have to input the mean as 65, the standard deviation as 2 on 3, and also the area, right? Or as far as the area, which is 0.01 in this case, right? The reason it's 0.01 is because when we talk about confidence intervals of normal distributions, we mean that there is 98% here in the middle between the lower bound and the upper bound, and therefore there is 1% here, right? So 1% is what we're looking for, 0.01. And then that's going to give you the lower bound. And yeah, based on the answers I got 63.4 as a lower bound. So the only one which satisfies that is D.
I think a couple of people asked, how would you recommend preparing, like 2 days and 1 day before the Spesh exam? What are your thoughts on that?
I guess like not do any more papers, just like I guess look through some of the hard questions that you've done in the past, and you feel like if that come in the exam, there might be a chance that you don't really get it, and yeah, and that's pretty much it.
Guma asked me, can you get an interview with 99th percentile UCAT 98 ATAR? First of all, I don't think you should like think too much about your ATAR before it actually comes out. Like who knows? A lot of things happen. And I'm pretty you should be able to get an interview. Especially with an excellent UCAT score. So congrats on getting that UCAT score, by the way. It's very, very tough to get 99th percentile. Menu 661. Okay, I don't. Oh, I'm interested to hear your answer to this. What subject score were you most scared about seeing?
Subject score. I guess English, because I feel like English is the most uncertain one, right? For math, I can just like obviously I compare the answers, and I feel like I know how well I did as I walk out of the exam room. But English is really like I don't know if I'm gonna do well or do bad.
I think I'm opposite to Gordon. I like English because you have a gist of it, and also you don't know your results straight away. But like I could feel how well I did. Whereas with maths, like I never did well. I guess maybe I have like trauma from that. But like because you know what you got wrong, so it's more painful. Whereas uh, yeah, for English, I felt like I could really like you can write a word wrong, you can spell stuff wrong, but as long as your overall thing is written well, you'll do well.
True, yeah, true.
Someone last year got into medicine with a 78 ATAR. I don't know if that's the case, but there might have been rural, they had C's, different types of things like that. If you don't really have those in your background, then you probably do need quite a high ATAR. Yeah, like refrigerated said, sort of disadvantaged backgrounds. And last question, do you have any advice for anxiety and fear of making a mistake that usually slows you down? Like being over paranoid in the exam?
Actually, I sort of have that, but I sort of don't as well because in the exam I was actually like trying to purposely slow myself down just so that I don't get anything wrong or like I'm confident with my first version of my answers that I don't feel panicked to have to leave time to go back and check again. But I guess if you feel like you're doing too slow, um, I guess you just have to like increase your speed about a little and see how that affects your accuracy and like adjust based on that.
Yeah, I'd say two things. One, like practically, try and find ways of checking your answer, especially for exam two, which is coming up. You can CAS a lot of these things to check your sort of initial calculation, like asymptotes and stuff, right? You can check if it's actually an asymptote, and that usually gives you confidence. Also, if you think about like slows you down, right? You can also think about it in the way that if you get too paranoid, you'll actually cost marks later on. So there's like a balance. You just got to get to a certain stage where you're quite confident, but you don't want to sacrifice a ton of time, and that's about the moment when you should move on to the next question. Wait, how did you like avoid sort of like copying a number wrong or something like that? Did you just do it slowly? Is that how you?
Yeah, yeah. I guess my strat for that is just doing really slowly.
Oh, cool.
Or just like every step I do, just look back and make sure there's no like really, really easy mistakes.
All right, I think we'll finish the last two questions and then we'll get to the rest of the questions. Like we'll finish the last two Spesh questions.
Yep. Okay. So here we need the variance of we know the variance of z is just equal to variance of ax plus by, and by formula that's just equal to a squared variance of x plus b squared variance of y, and that's equal to the variance of z, which is 90. So variance of x and y are both 9. So a squared plus b squared times 9 equals 90. So a squared plus b squared equals 10. And same thing, expected value of x is expected value of ax plus by. And by formula, that's equal to aex plus bey. And we know that x and y both have expected value or mean of 4. So 4a plus b is equal to 8, the mean of z. So a plus b equals to 2. And with these two conditions, you can just look through each of these answers and verify. And the one that I got is C.
You can also go backwards as well. Like you just say like you shove it into the formula, assuming you know what the ax plus by is.
Yep.
To check, yeah, cool. Yeah.
Yeah, and for the last question, when we're doing hypothesis, the p-value, in my understanding, is just what's the chance of getting a more unlikely answer than what we got. So in this case, we know that we know that the mean is 0.5 and the standard deviation is 0.2887. But obviously we took a sample of 100 random numbers, so we need to adjust the mean and standard deviation. But the mean in this case, p hat, will still be equal to 0.5, which is the standard deviation is now equal to 2887 divided by root n, right? So n is just 100 here, so that's equal to 0.02887 instead. So now when we have that, we need to find the p-value, right? The p-value is just actually normal CDF, and we input the mean, we input the standard deviation, and we do lower bound as negative infinity, and upper bound is 0.4725 because this is a one-tailed because it's suggesting that the mean is less than what it actually is. So when you pop it into that into the cas, the p-value for this is actually just b.
Cool. All right. I'll go to the physics page, but we'll answer some of the questions. All right. So we'll be getting on to physics after these questions. What should we include in our bound? Oh, did you do short answer first in both chem and physics, Gordon? Someone asked you that.
Did I do short answers? I did multiple choice first for both.
Angelin asks, what should we include in our bound reference?
I guess what you should include in your bound reference is anything that you know how to use, but you can't really remember, right? But obviously, like if you feel like if you're in like a nervous condition during the exam and there might be like some memory blanks, then you can include it. But most of the formulas are actually already in the formula sheet provided at the end, anyways. So
yeah. So I guess it's unrealistic to create a full book of notes because there's 2 days to the exam. I would say what I put was a couple of CAS things. Like I remember Euler's and differential equations. The CAS is a bit convoluted, so you can sort of write down what you need to actually put in the notation. Also, you can put in like some like stuff that makes you happy or something, like a, I don't know, like a quote or something. Isaac asked, "Oi, Darren, what do I put in me bound book, mate?" Demarcus Cousins, what pencil did you use for exams?
I actually used a pen. I mean, I did use a pen for pencil for graphing.
Did you use the Muji
But
pen?
I can't. Sorry, Muji pen, yeah.
Isn't it like, doesn't it smudge or not?
Not really.
Oh. Yeah, I used pencil for both maths exams because I felt like it was quite how do you say it? Quite stressful using pen. Someone asked for question 19, if the question doesn't specify independent, do you use a times variable x plus b times variable y?
Do you mean like a squared variance of that?
I assume that's what he's asking. Sure.
Yeah. You just assume that it's independent. Yeah.
What if it doesn't specify independent?
You just assume it. Yeah.
Oh, okay, cool. Yeah, they say sometimes you square it, sometimes you don't. How do you know when to apply what? Let's have a look at the question. It says independent, so yeah, like it literally says independent random variables. Yeah. Mikhail, Darren, I'm finding some content on specialist hard. Is this normal? Yeah, it's normal. Specialist is hard no matter what year you're in. Okay. All right. I guess we'll get started with physics then. Let me scroll down to physics. So we're doing all the MCQ plus questions 4, 6, and 9. So if you don't do physics and you only do Spesh, then I guess goodbye for tonight. But yeah. Oh, do many people who do physics do Spesh at Scotch last year?
Yeah. Yeah, I think most of them did.
Oh, okay.
Because it's like a combo. Because usually people just say like, if you want to do Spesh, might as well just do physics.
Right. Yeah, I think I would have done physics if I like had another subject to do.
Yeah. I mean, you did 7, right? Or just repeated methods.
Yeah, I guess I could have done physics instead of repeating methods, perhaps. But I guess it would have taken more effort, though. No worries, Lockstar. He says thank you, so no worries at all.
Alright. Okay, I guess we'll make a start on the physics.
Yeah, go for it. I am on the page.
Okay, so the first question is to identify whether the charges are positive or negative. And something we know is that the field lines always points away from the positive and points towards the negative. So in this case, because the field lines are pointing away from the charge itself, so these must both be positive. For second question, we want to find the magnitude of the surface gravity, right? So the formula for gravity is that it's equal to gm over r squared. So g is obviously the constant of 6.67 times 10 to the power negative 11. And we just have to times that by the mass, which is 1.5 times 10 to the power 23, divided by r squared. So that's 2.6 times 10 to the power 6 all squared. And that will give us 1.48, which is approximately 1.5.
No worries, Jack. Have a good evening. Also, I'm just here for moral support now. Like, I have no clue what's going on. This is physics. And Colby asked, do you think 30 and 71 on the two methods exams will get you a 40? I think if you go in the past years, you search up VCAS statistics, you can check what score you need for an A+, which is a 40. But I don't know. I think that's close. Might be a bit below a 40.
I think it's round the mark.
Yeah.
Okay. Yep. So for the next one,
it might be a 40 though, as well. I'm not too sure. Just check the past exam.
the next one is that when we have a particle entering magnetic field or a charged particle entering the magnetic field, because it travels in circular motion, that sort of implies that the speed of the particle doesn't change. Like this is a force and acceleration, but the acceleration is centripetal, which means it only changes the direction of the velocity, not the magnitude of the velocity. So the speed doesn't actually change. So here, it'll just be the speed which it enters with. And the question 4 is, they changed the speed of the positron to be 7 times 10 to the power 5, right? So the formula that we have is R equals mv on qb. And here, because r, or the speed, the velocity, was initially 1.4 times 10 to the power 6 and is now 7 times 10 to the power 4. So it's halved, right? So with the half velocity, because the velocity itself is half, the radius will also be half, right? Because they're proportional. So the radius here will just be r on 2.
Yeah. Do you think it's worth repeating methods if I got a high 30s, considering if I got a 40? Look, I think there are a lot of factors I'm happy to discuss further with you about why you should repeat a subject. You need to consider what other subjects you're doing, whether you like for me, I had to pick up another subject in year 12 as well. So those are all sort of considerations to make. And also what ATAR goal you have, whether a high 30s or a 40 will really affect that or not. But that's, quite important. Oh, someone's doing physics without doing methods or Spesh. That's interesting.
Yeah.
Alright, Q5.
Q5, yeah. Q5. Q5 is just finding the flux. So the flux is obviously just the magnetic strength times the area. So in this case, the area is 10 centimeters squared. So we need to convert that to meters squared first. So that's just going to be 0.001 meters squared. And times that by the magnetic field strength, so 0.03. 0.03. And the final answer that we get is 3.0 times 10 to the power negative 5. Oh. Which is B.
Someone asked whether methods is harder or physics.
I think methods is definitely harder.
You didn't do that many physics exams, right?
Yeah. I definitely did more for methods. Physics is, if you understand the concept, it's really easy to apply. But method is like, I guess even if you understand everything, they still might give you questions which can like trip you up or like is really hard to understand what's going on.
Yeah.
Yep. So the magnitude of the average induced EMF is just equal to n times change in flux over change in time, right? So obviously the change in flux here is just the b times change in a over change in time, where because n is already equal to 1, so we don't need to consider that. So that's just 3.5 times 10 to the power negative 4 times the change in area, which is when I move from none of the coil be inside the magnetic field to all the coil be inside the magnetic field. So that's just the change in area here is just going to be the area of the loop itself, which is 0.05. And then we got to divide that by the time, which it took, which is 0.20. So that's going to give us an answer of approximately 8.8 times 10 to the power of negative 5 volts.
Yeah. No, that's good to hear, Mikhail, that you did well because of my videos. Glad to hear that they're helping you out. Refrigerated has a pretty long question. Do you want to read it? It's like, I don't understand it because...
The DC motor with slide rings oscillate vertically before stopping in the vertical position. So when we have DC motors, typically it's like a continuous rotation. It doesn't stop.
Okay.
Okay, yeah.
And go to
Anyways,
Brandon.
moving on.
Yeah, go to Brandon. I don't know what that is. So if you want to explain, then sure.
Yeah. So this one is actually a trippy question because transformers actually only works with AC voltage. So here, the output voltage would just be equal to 0.
That's such a dog question.
Yeah, it is.
Do you remember doing this? Like in 2019? Like how do I say it? Do you remember doing this exam?
Yeah.
Did you realize this like straight away?
I think I was like, I went back to check it. I was like, wait. So if I didn't check, I think I would have lost that one.
Oh. So yeah, what the heck? All right.
Yeah. So with question 8, because the ball is traveling circular motion, right? When we have circular motion, there is a centripetal force of mv squared on r. And what that basically means is that is equal to F net. So at this position, the only force or the net force that the ball is experiencing is essentially an upwards force, right? So if you look at A or B, if you look at A, then the net force would be a leftward force, which is obviously not right. And same thing with B. B, the F net will just be a force component going to the left and force component going to the going upwards, which means a diagonal force, which is not what we wanted. If we look at C, then the F net will be a downwards force because the downwards component is longer than the one going up. So the only answer left is D, which has a net force of going up.
Cool. Do you still have your summary sheet? Someone's asking for physics.
Yeah, I do. Yeah.
How long do you aim to finish the physics exam in?
I aim to. I guess I feel like every physics exam I do is like pretty short. You always finish you always have some time left after you finish. I guess a good time is probably like 1 hour 45 minutes or anything before that.
What do you do in reading time?
So in reading time, I just do the same thing with like method and Spesh. I just read through the multiple choice questions, so that like when I start, I can like breeze through the MCQ really fast and leave a lot of time for extended response, where I may like need to think a lot.
With extended response, did you do like it a question at a time, or did you read like all the questions, all like the A, B, C, D, E first, and then do it?
I'll just do it one at a time. Because I feel like after I do the previous questions, it's like easy to see the link between like it and like the following questions.
And how much time were you like left with after finishing your physics exams, physics practice papers?
Visit practice paper, like I guess like 1 hour or less, but around that.
Well, you had an hour. What do you do? You just like sit there and like.
No, like, well, if it's like a practice, like if I don't feel like it, I just like end it early.
Yeah, fair. What did you put on your formula sheet?
Formula sheet, like a lot of it is like explaining, because I feel like explaining is like the hardest bit of physics. I mean, obviously there's like formulas as well, but like graphs and stuff. But because obviously like you get a lot of space for the physics sheet. It's like a double-sided A3, so you can essentially put like everything on it.
Emmanuel, do you reckon he could show us? I think that's something you can ask Gordon.
Maybe like daring to make a post like after the stream or something, and you
Yeah.
guys can.
Yeah, sure. Sounds good.
Yeah.
Yeah, so I think Gordon said in the exam, he took in the actual exam, how long did you take?
Like similar sort of time, maybe a bit longer actually. So like, I guess 1 hour and 45 minutes to finish, but obviously I spent like the rest of the time checking as well.
Cool. All right, question 9. Oh, this is like a Spesh question.
Question 9. Okay. So the logic for this question is that because these two objects are connected, what's going to essentially happen is they're going to travel as a unit, which means they're going to have the same acceleration. And if they have the same acceleration, because F equals ma, right? The proportion of force will be equal to the proportion of the mass. So here, the magnitude of the net force on 5 will be half the magnitude of the net force on 10, such that they have the same, so that they have the same acceleration. And the next question is just a simple question of applying the work formula, because work is equal to force times distance. So that's just 250 meters times 20 meters. So that's going to be 5,000 joules or 5 kg.
5 kg, yeah.
Yeah, 5 kg.
Someone asked, are you allowed to use formulas to shortcut in short answer questions? Yeah, you might want to read this. I don't really get it.
Are you allowed to use formulas to shortcut in? Yeah, you're allowed, yeah.
Cool.
Yeah, so for a satellite orbiting in circular orbit, obviously we know the speed or the magnitude of velocity is constant, because in circular motion, the centripetal force of mv squared on r doesn't actually change the speed, it only changes the direction. So, which means we know that the speed is constant, which means kinetic energy is constant. So C is false and A is false. And we just think about the momentum, right? Because momentum is actually a scaled, a vector, not a scalar, right? So the direction of the satellite actually matters in this case, which means because the direction changes, the momentum is also going to change. So we end up with D. And for 12, the Lorentz factor has the formula of 1 over 1 minus v squared on c squared, right? So that's just 1 over root 1 minus 2.5 times 10 to the power of 8 squared over 3 times 10 to the power of 8 squared. And just put that into a calculator and you will get 1.81 approximately. So A. Okay, the next one is conversion of mass into energy, right? So the formula we can think about is E equals mc squared. So m in this case is 6.6 times 10 to the power of 9. And c squared is obviously just 3 times 10 to the power of 8 squared, right? And because the rate is 6.6 times 10 to the power of 9 per second, so the energy generated will be per second as well, that per second. So that's just equal to 6 times 10 to the power of 26 joules per second, and joules per second is just equal to watts, right? So C in this case.
That's like the first time I've ever seen like E equals mc squared used.
Yeah.
It's such a classic like formula. Yeah. Also, good luck, Zero, for your economics exam and your future exams as well. And no worries for sort of doing this. And he says thank you to you too as well.
No worries. Okay, so for question 14, the diffraction or the greatest diffraction will be based on the ratio of wavelength divided by W, or the width of the gap. So in this case, lambda over W for the first case is equal to half, and here it's equal to 1, and here is equal to 1/3, and here it's equal to 2/3. So the greatest will be B.
Yeah, a lot of you asking about Gordon's cheat sheet. I think I'll discuss it with him afterwards in terms of what he wants to do with it. Because it's like his cheat sheet. But I'll let you guys know what happens.
Yeah. Okay. So question 15. So there's two ways of looking at light, right? Because light can take form as particle or as a wave. So if light is interpreted as a wave, then obviously its energy is proportional to its amplitude, right? Which means I will be a correct interpretation. And if you look at light as a particle, then obviously we know that its energy is proportionate to frequency, right? So with increasing frequency, the energy of the light will increase. With decreasing wavelength, that just means increasing frequency, right? So that will also increase the energy. So in this case, all three are correct. Okay, and for question 16, we know that EK max is equal to HF minus W, right? Where W is the work function. So essentially what this means is that a W is the y-intercept of this graph, right? So if we imagine what's going to happen, if we extend the graph a little bit, then we know that the one with the greatest the work function will be the one with the lowest y-intercept, which means lithium, right? Lithium and then sodium and then potassium and then nickel. So in this case, it would just be D.
Yeah, these questions seem to take a lot less time than like a Spesh question.
Yeah. Because physics questions are all really straightforward. There's not that much like reading or like thinking.
Not much thinking.
I mean, there's compared to Spesh, where there's like a lot of application questions, it's not that bad.
Yeah. It looks like there's like a lot of like you just apply the formula.
Yeah.
You get the answer.
And for question 17, which results in the emission of a photon with the most energy, right? So for an emission to occur, the atom must move from a high energy level to a lower energy level. So A is actually an absorption. So A is not an emission. So, and when we compare B, C, and D, because C travels the highest distance or goes from a high energy state to a low energy state that has the greatest interval between them, it releases the most energy. So in this case, the answer is just C.
I could have done this question. It's like chem, isn't it? This one.
Yeah. Sort of. We learned it in like Chem 1, 2 or something as well, right?
Yeah.
Yeah.
Someone asked, where should I start with my help sheets? His past SAC ones are roughly 10 pages. should I just minimize these or do something else?
Yeah, I think definitely try to minimize them.
I think by minimizing means like just make them smaller, but it'll put them all on the A3.
Oh, I mean, I guess you can, but it's if you can still see what's in there.
Also, hello. Thanks for joining. I saw you early today, but yeah, thank you for joining the stream.
Yep. Okay. And for question 18, that's just a definition question. A quantized energy level just means electrons behaving as standing waves. Only particular wavelengths are allowed.
Okay. Very difficult. Yeah.
Yep. And question 19, that's also a very general knowledge question. What's the hypothesis? It's a test for scientific explanation.
Do you have to like? Is there a lot of these that you had to memorize, or do you just learn it from like doing questions?
Like definition questions. Like it's you sort of like get application questions with it, which helps you to understand as well.
Okay.
Yeah, and for question 20, the formula for EK max is HC divided by a lambda minus work function, right? So obviously, if you just think about H and C as constants and W as a constant, it's sort of similar to a hyperbolic graph, right? So B.
Did you were the sacks harder at school?
The sacks,
Yeah.
I think they're like pretty similar to the exam.
Oh, okay.
The like sack average for physics was so high. I was like 90%.
Right. Yeah. What do you think about the method's grade distributions? I don't like in general, or what they were last year, or what's your like specific question? Yeah. I'm surprised it is not that competitive to get high 40s in physics, considering it's relatively easy. In further, I'm pretty sure it's 1 mark equals 1 study score. Do you have any idea why that is?
I guess obviously I haven't done further, but from what I heard, like further is a lot of just putting into the CAS. I think physics is definitely a lot more concept. Like there's more concepts that you need to learn, and yeah.
Agario asked, "Do you have tips for understanding special relativity?"
I guess it's just considering like how like obviously it's like really hard to understand because it's like time dilation, right? But it's still just for just for the purpose of AC, you don't have to really understand everything. Like if it's just the application of formulas and doing questions, it's pretty easy.
Azana. Oh, for this year, considering methods was a lot easier. Well, then the grade distribution would be like more wide then, I guess. Like you, oh no, more narrow. Like you might lose the same amount of marks both years, but you get the same study score. I think for me, 2019, 2020 was not, like 2020 was quite a bit harder, I thought, than 2019. And I think I dropped 1 more mark in 2020, but I still got the same like study score. So I don't think it affects it that much. And DeMarcus, if you want to further discuss one of your questions, you can just email me or message me on Instagram. I think I have it in all my videos. But Gordon, do you want to put any way to contact you in the chat?
Sure. I'll just should I do like my Instagram or something?
Yeah, sure. Go for it. Simona, hello. You've sort of participated a lot in my videos. Thank you. It would be so much better if Einstein never existed. Okay. Was physics your easiest exam?
Yeah, I'll say so. I'll say physics is pretty considered as one of my easiest exams.
Okay. Alright, I think I pinned your message. Okay. Is it pinned?
It doesn't show for me. I'm not sure.
It's up. It's up, I think.
Okay.
Can you see it?
Yep.
Oh, what?
Wait.
I'll figure it out. It's all good.
Okay.
I'll scroll down to. So, are we doing question 4? Is that the first one?
Yep. Question 4 is the first one.
Cool. So we're going through 4, 6, 9. Not all the questions. All right. Here we are.
So this is a pretty standard gravitational field question. So the orbital radius is just the radius of the Earth itself plus the altitude, right? So here the radius is given to be 6.37 times 10 to the power 6, and we just plus the altitude, which is 600 kilometers, which means 600 times 10 to the power 3. And the answer we get is 6.97 times 10 to the power 6 meters. So for the orbital radius or the orbital period, we just use Kepler's law. So here we have T2 to the power 2 over R cubed is equal to 4 pi squared on Gm. So T is just equal to root of 4 pi squared R cubed divided by Gm. So that is equal to, if we sub all the values in, 4 pi 2, 6, 0.97 times 10 to the power 6 cubed over 6.67 times 10 to the power negative 11 times the mass, which is given in the data sheet at the back. And that will give you roughly 5.79 times 10 to the power of 3 seconds.
They give you the mass of it.
Yeah.
Is it of Earth or of the satellite?
Of the Earth.
Oh, okay. Yeah. I was like, hello, Nathaniel. Thanks for joining. I wish they had this in Spesh, like this little answer box. I think it's quite nice.
Yeah. Actually, yeah, physics is like a lot less strict with like significant figures as well, as opposed to chem.
Really? Like you just, what do you mean? As in?
Like, you know how in chem we have to like de-specified like digits or number of significant figures?
Yeah.
Physics is like you do whatever. Like you can leave it 2 or leave it 3 or leave it 1. It's
Okay.
all good. Yeah.
Good subject.
So explain how Icon satellites maintains a stable circular orbit without the use of propulsion engines. And all we have to write here is that the satellite is only subject or affected to force of gravity, right? And the force of gravity is centripetal. Or in other words, always towards the center of the Earth, and always constant. Because it's constant because the distance between the satellite and the Earth's center doesn't change. And what this means is that this sort of implies that there is a constant force net of mv squared on r, and therefore stays in circular orbit automatically, or without the propulsion engines.
Yeah, I found chem pretty hard. Chem was probably I wasn't that prepared for it, but it's a pretty hard exam. Honestly. What about you?
Chem?
Yeah.
I like chem. Like, there's a lot of interesting things you learn in chem, I reckon.
Oh, it's a good attitude. And Simona asked, what was your favorite subject?
I'll say like Spesh, probably.
Okay. For me, probably English or Latin, I would say.
Yep. So for this one, we need to find the change in gravitational potential energy, and that's related to the area under the graph here. So we're going from the surface of the Earth, which is 0 altitude, to 600 km altitude, right? So the entire area here. So the area here can be just computed, because it's a trapezium, right? So we find the average of the height, which is 9.8 plus 8.2 divided by 2. That's the average of the height, and then times it by the width, which is 600. But obviously it's in km, so 10 to the power 3. And that will give us the area which is 5.4 times 10 to the power 6 joules per kg. And obviously, to find the change in energy or change in joules, we need to times that by the mass of the satellite, which is 288. So change in E equals 5.4 times 10 to the power 6 times 288. So equal to 1.56 times 10 to the power 9 joules.
Cool.
Yeah.
Sam, I probably won't be able to do a Chem 1 considering how close the Chem exam is. Unfortunately. Look, I'll contact my friend. I might. We'll see. But I doubt it. Don't count on it. You can message me if you have questions. Ace asked, do you have any good study habits that you guys use in uni that saves time? You wanna? We do very different subjects, but you wanna go first?
Study habits. I guess just like going for like revising constantly because in uni they give you a lot less time to digest information, so it's very easy that you like forget like what happened at the start of semester when you reach like the exam periods. So I guess a good way to save time is just revise as you go and like enforce that memory.
Yeah, I definitely agree with that. That's something we have in similar. I halfway through the sem, I started really revising earlier years content, and that I think helped me a lot in the end of year exam. What else? Oh, I'd also say like for medicine, there's a lot to memorize, like muscles and stuff, but there's also like important stuff and things that aren't that important. Like you spend some subjects are not like you can guess some stuff in some subjects. Like we learn about psychology and some of the questions I wouldn't spend as much time memorizing. So I guess focusing on the important content as well. Whereas in school, I focused on like everything because you could. Oh yeah, question 6. My bad.
Yep. Question 6. So
what is this Squid Game?
Okay, yeah. So for this one, the flux through the coil decrease or increase. Well, it just depends on how the area changes, right? Because flux is equal to magnetic field strength times area, and in this case, because it's stretched out, right? So the area of a circle is always greater than the area of the oval, given that they have the same perimeter, right? So here the area actually decreases, which means the flux is going to decrease as well, right? The next one is to explain why ammeter registered current, right? So we're going to use Lenz's law for that, right? And Lenz's law basically states that the induced current will oppose the change in flux, right? So Lenz's law. And what you have to explain here is because there is a decrease in flux into the page, the induced current will increase the flux into the page. And this will allow us to find the direction of the current because you have to mention that using the right-hand grip rule. The current will flow clockwise. Because the clockwise current will induce current into the page. Induce flux into the page, sorry.
Selim asked me, yeah, I think I know who Ali Shaban is. Yeah, I think I've heard of him. There are a couple Alis in the course, but I definitely heard his name. How do you know him? Emmanuel, could you explain right hand grip rule?
Okay, so the right hand grip rule is basically when you coil your fingers around a wire, given that your thumb is pointing towards the direction of the current, the way that your finger's curl will be the direction of the induced magnetic field.
Yeah, and there's a couple of similar questions in terms of with things like right-hand grip rule and Kepler's law. Do you have to like derive or explain them, or can you just say by?
You don't have to explain them. You just have to write them down or mention it, basically.
Okay. Yeah, he thinks it's unscientific, but I'm pretty sure that's just what it's called, right?
Yeah, there's no other name for it, so there's no other way you can refer to it.
You can find like, say like the right appendage law or something. Can you use dot points for this question? Oh yeah, do you have to use dot points, or like can you for?
You can, yeah, you can.
And how did you best answer worded questions? Tom Procard asks.
I guess a lot of what answering worded question is just putting in like the words or the keywords that they want you to write. And otherwise, as long as everything you say makes sense, it's good.
Yeah. Cool. Is there more to question 6? There is, right?
Yeah, there's one more question.
The physics exam, when I expanded it, I realized there's so many pages.
Yeah, yeah.
And there's a very big formula sheet right at the end. Is there? No, this is never mind.
It's like 2 pages. Yeah, okay. And then for this one, it's sort of like an extension to the previous question. So from figure A to figure B, right? The changes, we went from an oval shape to like a circular shape. So from figure A to B, there is an increase in area, right? An increase in area, and thus that implies an increase in flux into the page. And then obviously based on Lenz's law, the induced current will oppose the change in flux and hence based on the right hand grip rule, induce an anti-clockwise current through the loop, right? And for figure B to figure C, it's the same explanation, except that because the area is decreasing now, you got to oppose that change by increasing the flux into the page, and thus it'll be clockwise.
Do you have to rewrite it like again, or not?
You can like rewrite it with some simplification, I guess.
Yeah. I think someone asked can you for chem about like dot points. I think my teacher was really, really good. We're the same teacher, right? Yeah, we both at Peters.
Yeah.
Yeah. I think like with physics and chem, what they really want you to do is just say the words they want you to say, things like frequency, certain laws, and explain like how it contributes, like it increases, decreases, things like that. Sort of the fluffy words like the, like having full sentences, fancy language is not really necessary. You just really got to hit the marks, like get in and just get out. That's my opinion.
Yep.
How many practice exams did you do for physics? Like 5?
I can't remember, but like not that many.
Alright.
Not that many.
All right, question 9 then.
Yep. So question 9. So the ball was initially compressing the string and then it was released, right, causing the ball to move horizontally, which means that the initial velocity will just be the initial kinetic energy will just be the energy that's stored in the compressed string, right? So essentially we have EK, or change in EK is equal to change in UE, which is the elastic potential energy. So they're given by the formula half mv squared equals half kx squared. So obviously we can cancel the half, and we know that the mass is 0.2, right? So 0.2 v squared is equal to k, which is 1250, times the compressed length, which is 0.15 meters. So 0.15 squared. So V is just equal to 1250 times 0.15 squared over 0.2, and then put a square root all around it. And the answer I got for that is approximately 12 meters per second. Okay, the next one is to find the speed of the ball after it's fallen 2.5 meters, right? So the ball has an initial velocity of 12 meters per second horizontally, right? So v u of x equals 12 meters. But as we know, in projectile motion, the horizontal speed never changes, right? So it doesn't matter how far the ball has fallen, the horizontal speed will always be 12. We just need to find the vertical speed, right? So we know that the vertical acceleration is just given by the gravitational force, so negative 9.8 ms squared if you take down as negative and up as positive. And we know that uy, the initial vertical speed, is 0 because it was originally on the platform. And we know that the distance that has traveled vertically is negative 2.5 meters. So now we have this, and the thing we want is, the value we want is the final speed, right? So we want v of y. And v of y is given by the formula v squared equals u squared plus 2as. So that is equal to, so vy essentially equals to the square root of 0 plus 2, negative 9.8, and negative 2.5 all times together. And that's just going to give us 7 meters per second. And now we have the vertical speed and we have the horizontal speed. How do we find the total speed? Well, it's like Pythagoras. The vertical speed is 7 meters going down, and the horizontal speed is 12 meters per second. So the total speed, or the combined speed, will just be this vertical vector here, which is given by root of 7 squared plus 12 squared. So that's going to be 14 meters per second approximately. Yeah.
Nice. Is that it with question 9? Yeah. All right.
Yeah.
Oh yeah. Okay. So, couple questions. I think someone asked. I can't find it. Does rounding? Oh yeah. Does rounding matter in VCAR marking, such as 1.34 instead of 1.3?
In physics, it doesn't matter.
If they say significant figures, right, it matters for those questions.
Yeah, I guess, yeah.
Okay.
But usually they don't.
Okay, yeah. So usually you can just do it as many as you want. Yeah.
Mm.
If you guys have any questions, just drop them in the chat. We'll be happy to answer them. I think someone wanted us to go through some Spesh extended response questions. I think you have like a particular example. We can look at it. Are you happy to? Or next week?
Yeah.
Okay, yeah. If you have specific like exam specific question, just let us know. But otherwise, if you have any questions, just drop them in the chat as well. Emmanuel asks, Gordon, do you feel like physics is low-key repeated, the questions?
Yeah, I do feel like physics has a lot of repetition. I guess that's like sort of why physics practice exam was like so boring to do, in my opinion.
Yeah. Evan's asking whether you can go over rectangular hyperbolas. Do you reckon you could do like a minute like rundown in like a minute? Or like, I don't know how long it would take you.
Rectangular hyperbolas?
It's just normal hyperbola. I think it's just called rectangular. Like the ones that don't have diagonal asymptotes are called rectangular hyperbolas.
That don't have that do have or don't have?
Don't have. So like the really like the year 9 sort of younger year level ones we did.
Yeah. So I guess hyperbolas. Where should I write this then?
You see under question 9, C, like if you go down the page.
Yeah.
Move your arrow down. Yeah, just write it there. Bit of space.
I guess usually when we have rectangular hyperbola functions, it's written in the form of fx equals like a over x minus h plus k, right, in this sort of form. And in this case, what we can derive from this is that because we can't divide by 0, right, so x minus h can't be 0, which means x can't be h, right? And this is basically our vertical asymptote. So when we're sketching the graph of this function, then say h is positive, then they'll have a vertical asymptote, right? And what's also apparent here is that because x minus h can't be 0 and a is not 0, a is a non-zero, right? If a is 0, then it's just a straight line. So a is non-zero, which means that this whole fraction term is never going to equal to 0, right? So fx is never going to be equal to k because this term right here is never going to be 0. So k, assuming that k is positive, will also be an asymptote. It's a horizontal asymptote because y cannot be k. And what another thing is that when we're sketching these sort of graphs is we need to consider what a is. If a is positive, then we usually have a graph that looks like this. Obviously, I'm not paying attention to what the intercepts are. And when a is negative, it's just the other way around, or it's just reflected. Actually, not reflected. It's just will be on the other side of the asymptotes, basically. So it looks something like this. And I feel like that's pretty much it for hyperbolas.
Yeah. Very good rundown. I think 2 things I would add. One thing is you can sub in sort of numbers, right, to see which one it is, whether it's like how Gordon's drawn it or whether it's in the other 2 quadrants. Like you can just sub in a number, see if it's above the asymptote or not. The second thing is sometimes the way they like to trick you a little bit is by giving you an x in the numerator sometimes, and you got to like change it. You got to like divide by the denominator. Do you remember those kinds of questions?
Yeah.
And then that's sort of like a hyperbola in hiding, essentially. And you just got to long divide it. Refrigerated has a good question for you, Gordon.
Can you be the Women's Math Academy for physics? Don't have. I don't really have a plan to start a YouTube channel in the near future. So
yeah, I'm happy to like have Gordon put up the solutions or something on my channel. The issue is I don't have access to the papers. I think I probably need to contact the school or something. But to get like the 2021 papers as soon as people do them. But yeah, Worm gets a lot of views and stuff, and yeah, because he does it like the day after, like or on the day of the exam. And also that Austin guy. Do you remember, like from last year?
Yeah. But his solutions are like so messy.
Whose solutions did you use to check yours?
I think they used the Austin one, right? They just wrote on a piece of paper, like not even on the actual exam paper, just a piece of paper.
Wait, legit? Oh, okay.
Mm.
I thought it was on the exam paper.
Oh, maybe you checked the different one.
Could you possibly explain question 14, part B in the 2017 physics exam? We can have a look at that. I mean, yeah. I don't think Gordon has done physics in a long time, but we'll see how we go with that question. Are you okay if I download that?
Sure. 2017.
Or if you have like your practice exams, like the ones, if you have them still with you, you could probably look at like what you wrote for that question.
No, I think I chucked them all away.
Okay. Alright. Could you possibly explain? If not, you could get a ton of views if you did VC physics, since there's like no competition there. I mean, yeah. Do you want to do that? I'll see if I can get a hands on my. Oh, but I guess you have your exam soon as well. But I'll see if I can get my hands on the physics exam. I'll like message the school or something. Yeah, and 2017 Spesh. All right, we'll look at the physics one first. Oh yeah, how did you guys go so far? How did you guys find like the English exams? English language. No VC physics YouTubers, I guess. There's not many VC YouTubers, honestly. Start off. Okay, I think my thing just collapsed. Oh no, there it is. It will take a little bit to load. Oh. Yeah, how'd you guys do in your English exams? I will be interested to hear. Oh, how'd you guys find like the argument analysis section as well? Oh yeah, do you know the William and Troy topics and the ransom topics? Go on.
No.
I'll tell you. Let me find. Let's see. Okay, ransom was compare the relationships between loss and change, and compare how the two texts portray the fragility of leadership. What do you think?
I think that's, I don't know, pretty reasonable. Do you feel like these topics are easier than I guess we had a comparison for ransom, right?
Oh no, it is
So it's
comparison.
a bit
Ransom and the
different.
Queen.
Oh, it is comparison.
Yeah.
Actually, I feel like, do you feel like our topics last year was pretty easy as well?
Yeah.
Or no?
Yeah.
Yeah.
We got the
Yeah.
grief one and the public-private self. So that was pretty good.
Yeah.
And Women of Troy, 2 topics. One is complete bad. It's to what extent is Helen portrayed fairly in the Women of Troy? Yeah, that's just a dumb topic. And the other one was Eurydice play shows that there are no winners in war, which is easy. Yeah.
Yeah. Yeah.
All right. So this is question 14. Just let me have a look at this. Looks like there's an angle. Yeah, I'll answer some questions while you have a look at that. What's your opinion on Ransom and the Queen? Yeah, I think the Lost and Change one requires a little bit of thinking in terms of linking. And I think it can be really good to do well, but I would have gone for the safer one, which is Fragility of Leadership, because it's the exam. It's not the time to like show off. Only read 11 pages. That's a lot. Oh, you mean in total? That's still decent. Yeah, that's like satisfactory. I wouldn't say you would lose marks for that. That's excellent to hear, Refrigerator. I think there's a lot of adrenaline when you write the English exam. That makes you write a lot. Section C for English is so easy. Wasn't it like films versus books? I think it was. I don't have a copy of it. But yeah. Can you hear what you guys think? Yeah. I think English is more stock standard in terms of if you do well, you're gonna do well. Whereas in Lit, I know a lot of my friends who did well in SACs and stuff didn't get like the highest exam score, even though everyone thought they would. It's a bit more it's less consistent in that sense. And good to hear. Rear window prompt was good. Mikhail, welcome back. And yeah, I think 2020 was easier, but I think 2021 the topic, at least the leadership topic, is just pretty standard. But I just think the 2021s were like extremely straightforward. Can you see the exam, Gordon?
Yeah. I'm just trying to find it.
Okay. Oh no, it should be at the. Yeah, I scrolled it. Yeah, a little bit below. It's just directly below where you are. You moved up. Yeah, down a little bit more. No, up.
More?
Like zoom out, right?
Oh, okay.
Yeah, so it's like 3rd row on the very right. Yeah, that.
This one, right?
Yeah, like literally that page. Yeah. Yeah, I think it's the
critical angle.
I think it's part B for physics and part F for Spesh. If you look at the comments. That was just to a viewer. Don't worry about what I just said.
I don't think I learned this. Did I learn this last year?
If you don't remember, we probably got taken off the study design, honestly.
Yeah, I don't actually remember doing this.
Total internal reflection. Yeah. If you haven't done it, it's fine. We'll just there's someone asked a Spesh one as well.
Not 14. Question 4.
No, it says question 14, part B, in the 2017 physics exam. Yeah. All right. Do you want to look at the Spesh one then?
Yeah, sure.
All right. Yeah. Sorry about that smooth brain.
I mean, I think maybe the chat can help out with that question.
Yeah. All right. Or you can message me and I can try and find some other people who like have learned it or something. But yeah. All right. Quote 2017 Special Exam 2, question 4F. Let me download it. 2017 Special Exam. Oh, whoops. That's exam 1. Exam 2, right? Yeah. Exam 2, question 4F. Okay. Why does it just not give me? All right. 2017 exam 2. And I'll put it below, Gordon. Below the most recent physics one. Exam 2, 4F. Let's see, any other questions? Oh, I think people are helping him out. It's good. What did they say? Have I checked the England exam? 2020 exam topics were easier. So I'll go to 4F first. Oh, I remember doing this. I actually remember doing this. Yeah. But yeah. Latin is the most annoying subject. Too hard. I don't think Latin's that hard. I think it's just it's like pretty straightforward how to get better, but it just requires a lot of effort. Jack, I haven't checked the England exam. Please let me know how it is. I'm really curious to hear. Your English teacher made you write on every second line. Okay, for 17 pages. Yeah, that's an interesting tactic, but sure. Yeah, thanks, Jeffrey. Hopefully you're helping. Yeah, and Emmanuel and stuff. Hopefully you'll get it sorted out. Aaron as well. Thank you. Ace asked, did you get a scholarship into Scotch?
Me? No, I didn't.
It's a bit of a steal by Scotch, honestly. Bit of a hidden gem.
No.
You will also have partial reflection back in. Yeah. So thanks guys for helping Smooth Brain out. Yeah. Oh, I can probably find my exam for this one. Let me have a look. What do you think, Gordon? Are you going to work through it a bit?
Yeah, I'm just because I think we're meant to do this based on like previous conditions or something.
Yeah.
Just trying to find previous conditions.
you want to just do it from A, or you want to like think about it a bit?
I guess we can, yeah, sure.
Can't find my exam.
So for A, all we're doing is expressing in polar form, right? So R equals x squared plus y squared. This is equal to 4 plus 12. So that's equal to 4. R is equal to 4, and obviously theta equals tangent negative 1. Tangent negative 1 of 2 root 3 on 2. So that's just root 3. And because obviously this is in the fourth quadrant, because both an x and y component, or the imaginary and real component, are both negative. So in this case, the angle here will be negative 2 root 2 pi on 3. Yep. So which means the polar form will just be forces of negative 2 pi on 3. For the second one, I'll show that question. I mean, there's two ways you can do it. You can just do it by the quadratic formula or the completing the square. So if you want to do quadratic formula, so z equals negative b, negative 4 plus minus b squared minus 4ac over 2a. So that's just negative 2 plus minus, I think negative 48 on the inside. So I root 48, which is 4 root 3 actually. 4 root 3. That's going to be over 2 as well. So negative 2 plus minus 2 root 3 I, which is the question asked for.
Yeah, with question C, I think you just write like negative 2 minus 2 root 3i equals. Yeah, I did like 2 minus 2 root 3i minus 4 for the first root. And then the other one's like times by like negative 1, I think. Yeah.
2I minus 4?
Yeah, because that gives you the first root, right?
Yeah. And the other one is just negative of that, right?
For the first one, there's another way to do it where you like multiply, which I think is more appropriate because it's a bit weird when you say in terms of and then you just do a negative 4 at the end. But I think both is fine. It's not that big of a deal.
Yeah. Okay, yeah.
Yeah. Yeah.
I guess, yeah, the another way is just you use conjugate or something.
Oh, yeah. You do. Yeah.
You can put a conjugate on top. The Cartesian form of the relationship, I mean, this can just be expanded. So magnitude of z equals magnitude of x minus 2 plus y plus 2 root 3 I. So which means root actually we don't need the root. X squared plus y squared equals x minus 2 squared plus y plus 2 3 squared. And after some expanding, you can just simplify that to x minus root 3 y minus 4 equals 0.
Yeah. I guess the main part's question F. It's you just do a bit of algebra here and you get the answer. Because it showed that you do need to show more steps, like in the actual exam. But yeah. Cool.
Yep. So I guess we can pull out the solutions. So the root is negative 2 plus minus 2 root 3 I, right?
Oh, there's question A at the top. Oh, is it unnecessary?
No, I'm doing question E.
Oh, okay.
So it'll be here and here, right? So you can name that Z1, Z2 if you want. And the line is y equals 4.
But isn't it equidistant from 0, 0 and 2, negative 2 root 3?
Yeah.
What's the
So I guess
Oh, the solutions. Oh, okay, right. Yeah, my bad.
yeah. So for the line, you can just express it like this, right?
Yeah.
Or another way to think about the line is that it's equal distance from these 2 points. So the point is 0, 0, and the other point is 2 minus 2 root 3. Yeah, so 2 minus 2 root 3 is here. So it's the equal distance from these 2 points, right? So
Yeah. I think it's
you
easy.
can draw a line here and then draw a parallel to these 2 points. Draw a line that's parallel to these 2 points.
Yeah.
And yeah, obviously you can just use that equation if you want to find the intercepts and stuff. Okay, now is to find B in terms of A. So the line passing through the 2 roots is just this line, right?
Mm-hmm.
Which is just x equals to 2 essentially.
So they have the same I coefficient, right?
Yeah.
Two roots.
I think one of the ways is to expand it, but I think that's not what they want us to do.
Yeah, I think it's like B equals A like minus something or plus something because you only need to like minus like the real component, right?
Yeah.
Yeah. Pretty sure I did this like a really hard way when I did the question.
So I guess the point here is that to get a line, because the definition of Z, magnitude of Z minus A equals magnitude of Z minus B, basically means that a line such that any point on the line is equal distance from B and A, right? So if we imagine points on this Argand diagram, let's say like 1 and negative 3 could be a potential answer because this line here is equal distance from a negative 1 and negative 3, right? So if we think about the points that are similar to these set of points, we can think of something that's here, or something that's here, or something that's here, right? But one of the conditions that they must satisfy is they must have the same imaginary component, right? And the distance between these two graphs, these 2 points, must be equal to -2, right? Or the average of the x coordinate must be -2, right? So if we think about b plus a conjugate, that basically means because b and a must have the same imaginary component, b plus a conjugate will have a 0 imaginary component, right? So it's something plus 0I. But we also know that the average value of the real values of these two points must be equal to -2, right? So which means this must be -4 because the average is -2. So the sum must be -4. So find b in terms of a, then b must equal -4 minus a conjugate. That makes sense.
Damn, that's very, very impressive. I think Gordon deserves a round of applause for that question. It says I just searched it up. It says 1% of people got it right. Yeah. So I think the way I did it was I actually like subbed in numbers like A, B, like X, Y, and stuff, which takes a lot longer. But yeah, I couldn't really see this way when I did it. Yeah. Okay. Like Refrigerator said, it's hard. A lot of people saying you get a lot of DMs, but I mean, if you guys have questions, I'm sure Gordon's happy to at least read your questions and then whether he replies. No. Exam report doesn't say how to do it. Yeah. So did you guys understand sort of Gordon's explanation? Anyone have tips for literature? I didn't study literature. Yeah, I don't think my tips would be very useful. I think just, as always with English, you got to be very specific with what you're analysing. You don't like BS, because they can tell. What did you guys think of this year's methods exam? What did you think? Go on.
This year's methods exam, I only looked at section A. I think section A was alright. It's not like especially difficult or especially easy. It's pretty average, but I think it's a bit easier than last year, probably.
Yeah. Hello, Josh. Welcome. Josh has a YouTube channel, by the way, where he also goes over VC content, if you guys are interested. Yeah. If you have any questions, drop it in the chat. Otherwise, we'll end at like 10:30. Does that work with you?
Yeah.
Alright, cool. Are any of your exams open book? Gordon, are any of your exams open book?
Sorry?
Are any of your exams open book?
Open book? You mean in uni? Or
yeah, in uni.
I don't think so. I don't think I've done an open book one.
Oh. Yeah. Refrigerated wants another explanation of your answer.
Okay. So for this question, what z minus a equals z minus b means is that the distance from a equals to the distance from b, right? So let's think about a point such as -3, 0 and -1, 0, right? If we sub that into the values of a and b, essentially it means that the distance from this line. So take any point on this line, and its distance from -3 will be equal to the distance from -1, which is true in this case. So which means that -3 and -1 is a viable solution for A and B. So when we think about other solutions that can work for this, we realize that such as these points, we realize that such for the solution to equal this line of x equals -2, the imaginary component of the A and B must be the same, right? So say if I had, let me use a different color. Say if we had A and B with different imaginary components, then the line that will be equal distance to both points will be something like this, right? And that will not be equal to a vertical line, the line that we want. So that's the first observation. And the second observation is that so if I take the real value of A plus the real value of B, and I take its average, that must be equal to -2 because the line is at -2. So another example for this, if I had -5 and 5 as my A and B, then the as my A and B, then Z minus A equals Z minus B will have a line that looks like this, right? Because every point on this line will be equal distance from 5, 0 and -5, 0. So that's two observations. And from this observation, we know that if we plus beta and alpha conjugate, because they have the same imaginary component, the beta plus alpha conjugate is going to have a 0 imaginary component, hence the 0i. And because the average of the real component is equal to -2, then the sum is going to be equal to -4, right? So -4. And hence B equals -A minus A conjugate.
Yeah, and this is a question you can put in your bound reference for Monday, I think. So you can sort of refer back to it. Maybe you can like screenshot this with like Gordon's face and my face, and you can put it in your bound reference. Yeah. This year's Spesh 1 was easy. You didn't look at Spesh, right? The exam.
No.
What exams are on this week? If you guys know, drop them. Be interested to hear. And of course, any questions you have. Otherwise, we'll end at 10:30. Do you find C harder than Python?
C harder than Python, yeah, definitely. Because Python is like a much more simplified language than C.
With our like lectures, they just put like a PowerPoint and they just talk. How do they do it for code? Do they like have like a screen share or something and they talk to you?
Yeah, usually it's like recording, right? And they can like make like really good animations with PowerPoint.
Oh.
That sort of gets to the point.
Okay. How long are they each lecture?
So every week I have like, I'll say like 2 hours or so of lectures and 2 hours of workshop. So
Wait, what? No, I mean like over all your subjects.
all my subjects combined together.
Yeah.
Probably just like 10 or so lecture. Actually like 12. More like 12, yeah.
Dang, that's a lot. I only have like
Yeah.
You go.
I said last semester I had more. I had like 15 per week.
That's crazy. Do you ever how do you like find the patience to watch them? Or are they good?
Well, half of them, it's not all lectures, right? So I guess it's not, obviously we have like a combination of 4 subjects that are like very different. So it's pretty easy for me to, because we're always switching what we're learning. So it's pretty easy for me to like grind through them.
Yeah, that's good. Do you take notes when you watch them?
For some subjects I do, for some I don't.
Spesh 2 and Chem and Physics. Wow, I think a lot of people are done this week, right? Once you're done with Chem, a lot of people. Oh yeah, Spesh is like the day before Chem. Whereas last year, Chem was like ages away from Spesh.
No, I think last year it was like a weekend away. This way it's not, it's like 1 day away.
Oh, it was a weekend away. Oh, true.
Yeah, I think so.
Yeah. Then I'm free. Yes. It is a very special feeling after that year 12 last exam. Did you feel that? Like after? Were you like?
Yeah, it's pretty relieved. I mean, especially because I know I did pretty well, so it's an add-on.
What advice would you both give for making less careless errors in tests?
For me, I would say like taking it slow, like make sure every step you confident with. Because if you like rush through everything, right, and then you get to the end and you like still and you get stuck on the last question and run out of time and you don't have time to check, you'll like be like pretty scared that you've made like some silly mistakes in the beginning. So I just like take it slow even for easier questions. Just so I feel like confident not having to check everything again.
I think 2 points to this. One is like figure out what strat works for you. I think Gordon likes taking it slow, whereas for me, at least my tutor told me, I never really figured out what works well for me, and probably why I didn't end up doing that well. But he suggested that you sort of rush through it and then you go back and check it later. Like you get on the verge of rushing through it and then you check over it later. But I guess also just keeping a note of your silly mistakes is really useful, and having strategies to defeat that. Things like being able to do the question in different ways. Also, like ticking off things. You know, when they draw graphs, they want you to like label different things. Like ticking them off afterwards is one thing I did. Has he done physics yet? Yeah, we just finished physics, like half an hour ago. I'll go back to the physics exam just so people know we actually did it. Let's go to. Yeah, we did questions 4, 6, and 9 for physics. Oh no, this is the 2017 one. Yeah, we'll just go on this page. Fifth exam in a row. That's pretty crazy. Yeah. Yeah, that's pretty tough. That's why I thought you know when we had our prac exams at school, they were like pretty tight.
Yeah.
I thought that was quite good because it prepared us well.
Yeah.
It was like morning, afternoon exams. You'd have that.
Yeah, for like the 4 days of like math in a row, we like didn't really have any time to prepare.
Would you say do multiple choice first? I did extended response first. And Gordo did multiple choice first. I just think it depends on you. Alright, I think I'll end the stream then. Yeah, thank you guys all for tuning in. I think we had like 50 something, maybe 60 something people at one point, which is pretty cool. And they're also like different people. I think that's the thing. Like people don't watch for the whole like 2 hours. It's like a couple minutes. So actually like a lot of people see it in the end, which is pretty cool. So yeah, good luck with your exams that are coming up. Gordon's cheat sheet. Do you know what you're gonna do with it? Gordon, a lot of people like.
Yeah, sure. We can post it. So I'll just send it to Darren after the stream, and he can.
Yeah, sure. Okay. Another question. What do you think about it?
As Mark says, I record your math errors. So I think it's a pretty good method of collecting like good questions, just so you can like look through them at the end of the year. How do I recommend writing them? I mean, just in any way that you can like understand or like know the point that you're like trying to like, what is the part of the question that tripped you up?
Yeah, I agree. Like try and generalize it so you can apply it to other questions. For example, like tick off if you forgot to label asymptote, don't write like I forgot to label asymptote. Write like, next time tick off each part of the question that they want me to do, rather than just saying like I forgot the asymptote, because that's not really going to help you in the future. And it'll probably be posted to YouTube, like where I announce my lives, like on community or whatever on my channel. It will probably be just posted there. I'm pretty sure I can post images there. But yeah, or I might have a link in my next video. But just check those 2 places, and you can just write something in the comments if you can't find it, and I'll reply. Anyway, yeah, thank you guys for joining, and thank you, Gordon, for the second appearance as well.
No worries. Good luck, everyone.
Yeah. All right. Good luck with your exams, and see you all. All right. Let me end the stream. All right. We're done.